It's soon going to be 2025 in a couple of hours, and this is probably going to be my last video in 2024. But I realized one thing. As the days and years, months, they all go by, 2025, 2026, 2027, in 5 billion years, we're going to get closer for the sun to become a red giant. That means a very inflated version of reversed gravity. So the sun is going to expand and possibly going to swallow Earth, or at least grill half of our planet. And also, there's a lot of pollution, there's a lot of greenhouse gases on Earth. So I think the next best thing is to entirely go find a planet in our solar system and make it our home. But make it terraformed, like make it a second Earth. And obviously the human population is growing so much. People are thinking, okay, let's do Mars because there are solar ice caps and it'll melt over time with giant lasers. That's for another video. But what if we terraform the hottest planet in our solar system? Venus. I mean, it's a dangerous idea. Let's do it. There are things crucial that, of course, Earth has that Venus doesn't. Of course, one, it has a ton of greenhouse gases, like 10 times the Earth. There's a lot of CO2 and that can be bounced around everywhere. Of course, another thing, it is very, very, very hot. The minute you step on Venus, you'll die. You will just burn, you'll just melt. And the third thing is that it doesn't have any plant life, it doesn't have any greenery, doesn't have any food, doesn't have any good soil, nothing of that on Earth, so we can't survive in a couple of days. Even if we had like a magical suit that could stay with the for a lot of time, so we don't die because of the burning. So even if we had a suit that could help us survive in that kind of atmosphere, we'd soon die out of food and air and stuff like that. So we should cool down Venus first, make it all snowy like a snow globe, and then heat it up a little bit, because then we'll have water. So we need to literally put Venus in the shade. We can't use any chemical composition or a very large vacuum, no, because Venus has a ton of it. It'll take a very long time, and that long time may be 5 billion years. So the best thing is to put it in the shade, which will only take 200 years. Yeah, 2 centuries is all it takes. We can have a giant mirror, literally in front of Venus, between the sun. Now, Venus, for the first couple of years, it will start to cool, and then at an unpleasant 31 degrees Celsius, it will begin to almost rain. Then after some years later, like maybe 150 years, it will reach an unbearable negative 81 degrees Celsius and then cool down after that. So we need like 3 mirrors, one which is like in a circular shape and is divided into many parts, unless you want it to crash into Venus and use a lot of money. And then the second part is that you need 2 mirrors just diagonal from Venus like that, so it doesn't make it into a solar sail and literally drift away and make it colder. Yeah. So it will put Venus into the shade, since light travels in straight lines, and after 200 years, it will reach an unbearable, more than that, negative 100 degrees Celsius, more than that also maybe. Well, thing is, we've achieved snow globe. But at some point, we also want to heat it up again. And that's when the tricky part happens. So if we remove our giant mirror, we will grill half of our planet. And plus, there's a ton of CO2. Yeah, so we've hit a standstill. But we can do this. We can take 2 more mirrors and slowly just navigate it around Venus to simulate a whole day, and that way we can balance enough heat. So if we slowly remove our mirror, like piece by piece, and at have some rays come on it, we can redirect them by using those kind of lenses or mirrors and then heat it up slowly or slowly and slowly. Also, by that time, we need to remove a ton of CO2. So we're basically focusing the atmosphere. There's a ton of CO2, very less oxygen, and we're sadly lacking nitrogen. Not a lot though. So what we can do, we would have to have a ton of CO2 removed, so we might have some compressed CO2 like how we get compressed natural gas. So we can have that CO2 compressed and then moved away into some other place. And we can get some water from Europa, which has 70% more water than on Earth. We can pull that in the form of ice, and then when it drops on the surface, it'll cool down, turn into water. We have some shallow oceans. But Venus, it doesn't have great nitrogen, so if we ever need nitrogen, we can always get that from Titan, which is from Saturn's moon, where we transmit the nitrogen as a compressed liquid or anything like that and transfer it to Venus. We've already actually have made transfers to Saturn in just 7 days, so that's pretty neat. So now, up till then, it'll take a ton of stabilizing and everything else for Venus to fully become a nice atmosphere. It should have 21% oxygen, 78 to 79% nitrogen, and a bit of CO2. Okay, so we'll also need phytoplankton and cyanide. So both of them are nitrogen fixation devices, things, and contain them into compounds, like nitrogen compounds for more complex systems of devices. Venus is not ready yet though. And cyanides, they were probably, it's estimated, that they were used when our young Earth was really hot, but they made a ton of greenery, and that's how trees, plants, animals, it was the soil for all of that to grow. And we can add them to the oceans and will gradually make land. So our shallow oceans are there, there's CO2 removed. Our first animals would probably be very tiny microorganisms, like maybe tiny seahorse or fish. If we're good and efficient, maybe even sharks. That'll have the food chain. And the first plants to have are probably normal plants and then probably volcanic plants, since that suits the atmosphere. If there's too much CO2, volcanic plants can be there. Now I'm going to divide everything into 4 tiny categories, and I will see what we have to do. If this video long enough, if you not understand everything, I'll say it in short. First, atmosphere. Mirrors on the Venus, in front of Venus, and here, which will cool it down into probably minus 100 degrees Celsius. Then after that, we want to heat it up. So we'll take 2 more sets of mirrors and slowly remove this mirror out. And then they can redirect the rays from the sun and heat up the planet again. Number 2, we want to remove CO2 and add a bit of nitrogen and add a bit of oxygen, if anything's needed. So we can get a ton of water from Europa, which is actually a moon from Jupiter. And it has 30 quadrillion, maybe even more amounts of water. That's a lot of water. And we can make shallow oceans from there. They can be in the form of ice, and we can transmit them through skyhooks. Skyhooks are like slings that just catapult the ice to the other way and then transfer it back to Venus, which cools it down, makes it into water, and then we have our oceans. Now, number 3, of course, the oxygen, the nitrogen, the carbon dioxide. So we can compress the carbon dioxide in a cylinder and launch them out into space where nothing is there. And of course, oxygen, if we need, maybe we can get some from Earth. Now, nitrogen, we can get some from Titan, which is a moon from Saturn. A ton of nitrogen. And we can always compress them into a liquid and boom, on Venus. Okay, now the third category, plants. We're going to add some starter plants and some animals or some fish, tiny fish of course. If they're suitable, we can maybe even add normal fish and maybe even sharks and more complex animals. Now Venus is turning green. But before that, we have to add a ton of, plants of course, or cyanides. Cyanides are basically the nitrogen fixation like phytoplankton, and they can make the surfaces for land where all the grass and plants are there. And they can also fix nitrogen, fix carbon dioxide into oxygen, you know what I mean. If Venus has a very poor magnetic field, let's say just in case, if it somehow loses its magnetic field and it's not strong enough, we can add an artificial magnetic field. It's like a giant umbrella which orbits at the Venus, in front of Venus where the mirror was. And it's basically a giant ring nuclear facility powered by, and it literally protects everything from radiation, cosmic rays, and everything like that, and it's made by us. So, in the long future, maybe it will be able to sustain us, and maybe Earth will get some relief. So that's all for today. So Happy New Year to everyone, and advance Happy New Year to the ones that are not here and on the western side. And it's just me signing off, but I don't have my speed today, so I'm just gonna say bye. Psych!